All right, so I wanted to do this last lesson quickly. It's easy. It's a good point getter for our last exam. So we're talking about real world graph scenarios. All right, so a train pulls into a station and lets off its passengers. All right, so if you're looking at this situation, what's happening? All right, so we gotta think realistic. All right, so I look at this one. Oh, 1 second. So I look at this and I see this, right? The idea is that, what is this graph showing? This graph is showing that the train is slowing down so that the passengers can get off. And from there, I kind of think about the other ones. So what does this mean? All right, this graph means the train's going 70 miles an hour and then just dead stops. So what is slammed into a wall, slammed into the station? Something not possible. This one's saying the speed is going up, then it's going down. The speed's going up, then it's going down. It's slightly getting closer and closer to an equilibrium line there. Right? I don't even know what this one means. Right? But the idea is here, slowing down, coming to a stop. A man takes a ride on a Ferris wheel. Right, so our answer is this. Right, because if you think about a Ferris wheel, you get on, here's our Ferris wheel. You get on, you go up and around, up and around, up and around. Right, there's a constant high point, there's a constant low point. Right, if we look at some of these other examples, here, this graph, this means that your body is in two different places at the exact same time. Right, as time goes on, at 5 seconds, your body is 10 feet off the ground and your body is 50 feet off the ground. Not possible. Right? This one is just a mess. Right? If we're going with that same idea, at this spot here, your body's in 3 different spots at that time. Not possible. Right? C, I think about C like this. You get on a Ferris wheel that's slowly collapsing into itself. Right? More realistic than A and D, but still not going to happen. A woman climbs up a hill at a steady pace and then starts to run down on one side. A. She's going a constant 10 miles an hour, and then she kicks it up to another gear. B. People like to choose B because B looks like a mountain. Right? B, this is your speed's increasing and your speed's decreasing. Right? C is the opposite, where you're increasing your speed and then you're going at a steady pace. D, your speed going is increasing forever. So at some point you're going to be running 5 bajillion miles an hour down the hill. Not going to happen. Right? Child swings on a swing. A. Think about it. As you start pumping the distance from the ground, you're starting to get higher and higher as you swing back and forth and back and forth. B looks to me like you're shot out of a cannon. C looks like you swing down. Right, here you are on the swing. You're on your swing. Whee! And the kid goes flying that way forever. D, I have no idea what D would be. Alright, 5. A child comes up a slide and then goes down it. Alright, so right away I'll tell you it's not B. People think it's B because it looks like a slide. It's C. Alright, so the child goes up the slide, and what happens at this spot? They sit down. They sit down, and they go firing down the slide, and what happens here? They reach the end of the slide. Alright, so all these graphs, they represent some real-life situation. There's an X, a domain, there's a Y, a range, right? And what do they relate to more importantly in this scenario? X in domain is your independent variable. Y in your range is your dependent variable. Time, as you see in these problems, time is your X. Time is your independent variable. Through all my years of teaching, I've seen maybe 2 problems where time is the Y. Right? As time goes by, this changes. The independent variable leads to the change in the dependent variable. Time leads to the change in your speed. Time leads to your distance from the ground. Time leads to your speed also. So that's the key scenario we have there. Now if we look at lesson worksheet 3, right, creating a real world problem from a scenario. Right, creating a real world problem from a scenario. We have an independent variable, we have a dependent variable. So here's our situation. A businessman returned home from abroad with a new and highly contagious disease. In the ensuing epidemic, which sweeps through the city, the number of people with the disease at any one time is related to the number of days since the man arrived home. Alright, key word, related. What I know is that what comes before the word related is your Y, what comes after is X. And throughout the year we'll have different words. One time is linearly related, quadratically related, varies. Alright, these key words separate the two things that we're looking at. And with everything, y equals mx plus b, y equals ax squared. Y comes from the x. How many people have the disease is based on the number of days since the man arrived home. So our independent variable in this situation is number of days since the man arrived home. So, independent variable, days since the man arrived home. And our unit for this is in days. Dependent variable is number of people with the disease. Oop, messing things up. And our unit there is people. Alright, so every time we do a problem like this, we want to label our axes. X, number of days since man arrived home. Y, number of people with the disease. Right, and again, our unit, days, our unit here is people. And now once we have this set up, we can make our scenario. Alright, so day 0, there's one person. There he is, the man. Right, so for this type of problem, we can create a scenario. We can create a story that goes with the work we have. Alright, so we could say his name is Tom. Tom flies home. Tom has an infectious disease. Obviously, this story is getting a little bit too real for us these days, but this is what we're going off of. Right, so what's the situation? Well, he lands at JFK Airport, he gets in his car and drives straight home. Right. Day 1, he's gone home and he's infected his family. He has a wife, he has 8 children, so him, his wife, his 8 children, now will have the disease. So after one day, we went from 1 person to 10. What happens next? Well, he goes to work. His wife goes to her job. The kids all go to school. So it's starting to increase. So maybe after they go to school and everyone goes to work, maybe we're at 1,000 people now on day 3. I'm at day 2. Day 3. Those 1,000 people go out. And they start going out and they're seeing their families, they're seeing all these people, and it's going up and up and up and up and up and up and up. So maybe we're at 100,000 people. But will this go on forever? Will this go on forever? In this scenario, no. I'm going to tell you it's not going to go on forever, because why? There's a finite amount of people in the population. So let's say I draw an asymptote. So let's say I draw the asymptote of y is 250,000. There's only 250,000 people in this town. So we're getting close to 250,000, but will we ever reach 250,000? Probably not. You probably got some people that don't go out. You got some people that hide out in their basement. Maybe you have some people that are away. So in this scenario, here's what we got. Day 1, you come home and infect your family. Day 2, your family goes out, infects people at school and their job. Day 3, all those people go to their families, they go to their jobs, and start passing people along. As we approach day 4, day 5, day 6, we're getting really close to the population of the city, but we never quite get there because, like I said, some people are out of town, some people are away, some people are hiding in their basement, and we're not going to get them. So there's my graph. That is the graph that I created based on the situation we have. You can all create different graphs based on how you come up with the story. Right? So after I made my graph, I'm going to write up my story. So what do I say? Tom flies home and blah, 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 blah. He sees his family, they go to school, they go to work, they infect each other. Right? So that's the scenario we have. And again, why did I want to go over this problem? I think it's a nice, easy point grab for you on the on Wednesday's exam. There'll be one problem like this where you're going to create a story. But I have to give this disclaimer. Do not go crazy with the story. I've seen people waste way too much time writing things and writing things and writing things. Yeah, get to the point. Day 0 this, day 1 this, day 2 this, day 3 this, and so on. I don't need paragraphs and paragraphs and paragraphs about a crazy, crazy, crazy story that you're creating. Right, so there's my situation. That's what we can go with. So on the next page, you got 2 more examples. Check the answer key up on Classroom and see how you're doing. Again, keep this simple. Don't go overboard. It's all in good fun. So work on this. Check the reviews. I'll have all the answer keys up in Classroom, and you'll be good to go for Wednesday.